How to estimate the diffusivity of a gas mixture using Chapman Eskong formula. So this is the question right here. Estimate the diffusivity AB of a gas mixture which constitutes of nitrogen and ethane at 288 Kelvin and 40 atm. So let's start. Solution. So using Chapman Eskong formula for an ideal gas situation. This is the formula. We have diffusivity AB equal to 0.0018583 square root of 3 raised power of 3 to bracket 1 over MA 1 over MA plus 1 over MB all divided by P multiplied by collision diameter AB square multiplied by road diffusivity AB, where P is the actual pressure from the question, and I have this as the collision diameter. So we have this ohms as the fraction of temperature and potential fade. That is fraction of temperature and potential fade. Let's say nitrogen is A and ethane is B. For us to get each of these parameters, we know that this actual pressure is from the question. And secondly, for us to get this collision diameter, checking this table overlay under Leonardo's constant, you can see something like this there without any alphabet. So check corresponding to nitrogen. That is collision diameter of A. Check corresponding to nitrogen. Corresponding to nitrogen, we have it as 3.687. With the unit of Armstrong. Check corresponding to ethane, that is collision diameter B. We have 4.388 Armstrong. The next thing is for us to get our collision diameter AB, which is equal to 1 over 2 to bracket collision diameter of A plus collision diameter of B. So which is equal to 1 over 2 into bracket collision diameter of A, that is 0.667 plus collision diameter of B, that is 4.388. So from here we have 4.028 Armstrong. This all for this collision diameter, how to get this parameter. So for us to get our fraction of temperature and potential feed now, this fraction of temperature and potential feed, which is given as ohms diffusivity AB, is plotted against against KT over E, where E over K is called potential field. And T is temperature. Is the actual temperature from the question. So the next thing to do, if you check that Leonard Jones parameter, you can see this parameter there, which is E over K. That is potential field. So check the column corresponding to nitrogen now. That is EA over K. So you can see it as 99.8 Kelvin. So check it corresponding to ethane. You can see that here we have it as 232 Kelvin. So for us to get the potential field for both AB now is given as EAB over K equal to square root of EA over K, that is potential field for A, multiplied by AB over K, that is potential field for B. So substitute the value in, we have square root of EA over K, which is 99.8, multiplied by EB over K, that is 232 Kelvin. So from here we have it as 152.163 Kelvin. Here we have fraction of temperature and potential field is against KT over E. So we all know that E over K is the potential difference. So we have that KT over E. Okay, let's say KT over E AB is equal to K over EAP multiplied by temperature. So where this K over EAB is the inverse of what? Inverse of E over K, that is 1 over EAB over K multiplied by the actual temperature, which is T. So the next thing we have, substitute the value in, which is 1 over 152.163 multiplied by the actual temperature from the question, which is 288. So we have it as 1.89. The next thing to do is, we already have our KT over EAB, in which fraction of temperature and potential field is plotted against. We're checking this other table overlay. So you can see something like this over there. So without any alphabet though. So check under that column if you can see this value, that is 1.89. So you can see that there is no 1.89. The value in which this 1.89 is between is 1.85, 1.85, and 1.9. That is, after 1.85 you have this value 1.89. So before you have 1.90. So that means 1.89 is between 1.85 and what? 1.90. The next thing to do is to check the third column. So you can see the second column had the same symbol as this function of temperature and potential field. So, and the third column had the same symbol. So you can see that the second one is for viscosity and thermal conductivity, while the third one is for diffusivity. So check under the column of the diffusivity. So you can see that corresponding to 1.85, we have it as 1.105. And check corresponding to this. This is what we are looking for. So you don't know the value corresponding to this. So check corresponding to 190, we have 1.095. Check it well. Don't make any mistake. So the next thing to do is to interpolate between these two values. That is between these two values for us to get the value corresponding to 1.89 that we are looking for. So that is by interpolating. Between 1.105 and 1.095. By interpolating, we have that is 1.89 minus this first value, that is 1.85. I'm showing you how to interpolate. You can use it in any course. So 1.89 minus 1.85 divided by 1.90 minus 1.85 equal to, you can do the same thing to the right hand side, that is x minus 1.105, that is the middle value minus the initial value, all divided by that is the last value, 1.095 minus the initial value again, that is 1.105. So just make x subject of formula. You have it as 1.097. Just make sure you get the value, interpolate between the value to get this. You can't approximate that 1.89 to 1.9 to get this value. It's very wrong. So make sure you interpolate to get your value corresponding to it. We have gotten our fraction of temperature and potential field now. So the next thing is to substitute all the parameters to the Chapman Eskong formula. So for us to get our diffusivity AB, so we have diffusivity AB equal to 0.0018583 square root of T cube to bracket 1 over M A plus 1 over M B. So all divided by P multiplied by the collision diameter AB square multiplied by fraction of temperature and potential field A and B. Next is to substitute. We have diffusivity AB equal to 0.0018583 multiplied by square root of, from the equation we have T as actual temperature, which is 288. So raised power of 3 to bracket 1 over, sorry, this square root 1 over molar mass of A. That's molar mass of nitrogen, so which is 28.01 plus molar mass of, that is 1 over molar mass of ethane, that is 30.07. So all divided by the actual pressure, that is 40 atm, multiplied by collision diameter AB, which is 4.028 square, multiplied by this, which is 1.097. So we have diffusivity AB equal to 1.274 centimeters square per second.